The objective of this lesson is I can work with circles to solve problems. This will be an introduction to circles and working with the lines and segments that are involved in it. So the first thing we need to do is really talk about what terms we're dealing with. First of all, the first term we want to talk about is called a chord. A chord, if you look at a circle, is where you take and you connect 2 points on the circle. So if you've got a point there and a point there, connect them, that's called a chord. So it's a segment whose endpoints are on the circle. Next, we look at a secant, and all that the secant is if you take that chord and if you extend it into making it a line, so it's a line that intersects the circle in 2 points, that's called a secant. So it's like a chord, it's just now we extend it and make it a line. So a line that intersects the circle in 2 points. Okay, let's talk about a couple other concepts or terms. Let's talk about what a tangent is. A tangent is the same idea with the line, only now this line instead is going to only intersect the circle at 1 point. So when we define it, it's a line that intersects the circle in 1 point. So notice the difference between these two. This is 1 point for tangent, and it's 2 points for secant. Now, point of tangency is just that point there. It's right there where the point of it's where the circle and the line intersect. So it's that intersection of the point of the line and the circle. So when we do that, we want to define it. It's the point of intersection That line, though, has to be a tangent. Okay. So next, let's go ahead and talk about what we do with circles themselves. So now we'll talk about congruent circles. And as you can imagine, two congruent circles, it kind of makes sense that if they're going to be congruent, it's going to have that their radii are congruent. So two circles that have the same radius measure. Okay. Concentric circles, on the other hand, think about that word concentric, and what we mean when we say concentric is that they have the same center. So if we've got a big circle and a smaller circle that share the same center, then those are called concentric. So circles that share the same center. And then lastly, for defining these types of circles, we've got tangent circles. And we really talk about this in two ways. We've got an external tangent, which is where you've got two circles where one of them is outside of the other one and they intersect at one point. And you've got internally tangent circles, whereas if you've got one of the circles that actually is inside the other and they only intersect in one point. So this is circles that intersect, just like a tangent line did, intersect at a single point. Well, good. Let's talk. Now that we've got some terms, let's actually talk about some tools that we will use when we talk about these different tangents and circles. When we talk about a tangent perpendicular to the radius, if we say a line is tangent to a circle if and only if, remember that means it's both the original statement and its converse are true, if and only if it is perpendicular to the radius. So if we've got a radius here and we draw a tangent to that radius at that point of tangency, that tangent and that radius are going to be perpendicular. All right, now we're also going to use this in terms of two segments that are tangent to a circle from the same external point. So if I pick a point out here and draw a tangent down to this side of the circle and one over to this one, notice those are two segments. I'll call the point out here P, and then the point of tangency is this one A and this one D. What we know is that those two segments are congruent if they come from the same exterior point. So we're going to say that segment PA is congruent to segment PB. Let's make this a B here instead of a D. So PA is congruent to PB for that. Now that's going to become very useful because we'll be able to use that to solve different problems. So now we're at the point of solving some problems. First of all, this first problem from the book, if you turn to page 797, this first one is just defining some different lines and things like that in this diagram. So the diagram lists a line L here. Okay, and line L is a secant. Next, the next thing it lists for us goes right through the middle here. Okay, and that's F and E. Okay, FE is a chord, and notice that chord we've also called the diameter since it goes through the center. Okay, and this is center D here. And then lastly, if we've got a line out here, they've got line M out here that intersects it in one point. So line M is a tangent. So it's just defining what those different segments and lines are in the problem. All right, let's do number 9. It asks us here to find JK. If we draw the diagram this way, we've got circle C, and we've got out here point J, and then we draw a tangent here, and we draw a tangent over here. So this is point J. This is JL here, and JK. It asks us to find JK, the length of that, but then it gives us these lengths of 4x minus 1, and this one is 2x plus 9. Now, those are algebraic statements, and so what we can do is use our statement that if you've got a point exterior to the circle, you can then set those two segments, since they're both tangent segments, equal to each other. So 4x minus 1 equals 2x plus 9. We solve that by subtracting 2x from both sides. We'll get a 2x on this side. Add 1 to both sides and you get a 10 over here. So you get x equal to 5. Now it doesn't say just find x, so you got to put that back in. So you're going to do 4 times 5 minus 1. That's 20 minus 1. And so you get JK equal to 19. That's our final answer. Alright, and then let's do our last one here. Let's do number 10 on this. So number 10 looks like this on that page. It has a circle P, and it draws two tangents, one from point S out here, tangent over here, that's to intersect at T, that's the point of tangency. That's a y minus 4. And then it draws a tangent over this way, and that goes to U, and that is 3/4 y. Involves a fraction. And so this one asks us to find ST. So let's first of all use our formula that says that we can set those two equal to each other. So y minus 4 equals 3/4 y, because they both they're tangents coming from the same point. So let's go ahead and bring the y's together. I'm going to subtract y from both sides. So if I subtract y, okay, I get left with a negative 4 on this side. 3/4 y minus 1y is negative 1/4 y. What might be helpful to think of that's like 3/4 is 0.75, and 1y is just minus 1. When I do that, I get a negative 0.25. So that's one way to think of that, which is negative 1/4. Now I get rid of the negative 1/4 by multiplying by its reciprocal, which is negative 4 on both sides. So I'll take this negative 4 times negative 4. Another way to have done that is you could have divided by that negative 0.25 that we had in this, we did in that part. So you get a positive 16 equal to y. So ST is equal to the y, which is y minus 4, which is 16 minus 4, which gives us a final answer of 12. So there's how we use the circle and these terms we've used with both circles and lines and segments to solve problems.